Hey, Jonathan. I was hoping you could introduce yourself and talk a little bit about your research.
Yeah, of course. My name is Jonathan Navarro Ramos. I am a second year, rising third year PhD student in the chemistry department here at UB, University at Buffalo, working under Dr. Diana Aga. And also, I am somewhat co advised with Dr. Ning Dai from the engineering department. The research that we mainly do in our lab, as a general approach, I would say, is to develop methods to detect and quantify environmental pollutants in a wide range of samples, such as mainly water, but we can do soil, food, tissues, for example, extracting pollutants from fish, and a wide range of other matrices. For me specifically, I am working currently on developing methods for sample preparation and also detecting and quantifying pollutants, for example, tire-derived chemicals in stormwater runoff. And I am also looking for using HRMS, high resolution mass spec, to do some non-target analysis to look for transformation products of some compounds that are tire-derived chemicals. Is in the works right now, but yeah, that's mainly what I'm focusing on.
Very cool, Jonathan. Yeah, I'm sure with the chemicals, there are a number of environmental concerns. Would you mind expanding on that?
One of the main reasons why we're interested in one of the antioxidants called 6-PPD. Most people know it, but for the ones who don't know, and 6-PPD is a antioxidant that is added in not only in tires but other rubber compounds or other rubber materials. They're added to prevent the cracking and I would say, of those materials, extending their lifetime. And this compound, when it gets oxidized, because it's an antioxidant, this material will get oxidized instead of the rubber itself, which is the main purpose of it. But the transformation product of this 6-PD is called 6-PD quinone, which is the quinone portion of it. And it is also being found in the environment at this point is ubiquitous, is found everywhere in the world, not only in the US. And some researchers, if I don't recall wrong, is in Washington University. And they're devoting a lot of time on the study of 6-PD quinone and finding them, trying to find them everywhere. This is something that we are also interested in our area over here. We're very interested in some of the tire derived materials because now these materials have been deployed in the environment very extensively, like everywhere. For example, children playground and track and field flooring. Even the tires itself have been used in gardening purposes, and turf grass also as another way that we're recycling these tires. We can be talking about a lot of all of these applications of end of life tires. And so we are very interested on the potential would maybe pollutants that could be leaching out from these materials in the environment, that when it rains it creates runoff, and this runoff just mobilize all these chemicals to the receiving waters, and these receiving waters will have all this wildlife, and we would like to know what are the toxic effects of these compounds, and not only 6-PPD, 6-PPD quinone, and other tire derived chemicals. So that's mainly what we are focusing on and what am I very interested in, because not only environmental concerns and wildlife concerns, but also public health concerns. There are also studies that have found 6-PD and 6-PD quinone in human urine, which tells us that this compound is everywhere. And we've been in contact with it, and not only with tires, but I would say this is a rubber world right now, where we're using rubbers everywhere, and so these antioxidants are being used in all these rubber products. So we are being in contact with those, especially children, right, with all the toys and all that. So yeah.
Yeah, that is certainly very concerning. I remember the first time I saw the recycled rubber at a playground, thinking, oh, that's cool. It's an alternative to wood chips, but certainly hadn't really thought about some of the environmental implications that you had mentioned.
Yeah, and not only 6-PBD quinone and tire chemicals, but also pHs. Not only we were looking for 6-PBD and other tire-derived chemicals, but also we were analyzing for pHs, for phthalates. Phthalates are plasticizers, so of course, and metals, heavy metals, because we know that metals are another portion of the tire itself. It was a very complete study that we were trying to assess.
That's great. Yeah, I thought your poster at ASMS was very interesting. And for anyone watching this who doesn't know, that's the American Society of Mass Spectrometry. If we could transition here, would you mind talking about how, or why I should say, LCMS-MS was the preferred analysis approach?
Yeah, of course. So LCMS for us, out of all the possibilities that we have here, fortunately, our campus has all these instruments and applications available for us. And LCMS, it's the perfect fit because when you look at the analytes are not volatile. Most of them are thermally labile. For example, let's compare it with GC. GC is an approach that the compounds need to be in a gas phase before going into the separation in the column, and some of them will break down even before getting into the mass spec. So that's another, I would say, physical chemical property that we have to look at. Also, most of our compounds, all of them are very hydrophilic. So they are good to go in our LC separation. In terms of the mass spec, MSMS, triple quad is perfect because it gives us a very high selectivity and sensitivity as well by taking out all the background as much as possible, so we can have very subpart per billion detection limits, which makes it a perfect fit for environmental samples because most of our environmental applications are in trace levels. So we need a powerful tool to give us the opportunity to look down to subparts per billion, even high parts per trillion. So I would say that it's a main reason why we chose LCMSMS over other separation techniques and detection techniques.
That's great. Very good. Regarding the sample preparation and the analysis, what were the main challenges you faced?
Main challenges I faced with sample preparation were the leachate samples from tire-derived aggregate (TDA) and crumb rubber. Those two samples where the sample matrix was a little bit challenging. You could physically see that it has coloring. We had to obviously filter out all the coarse particles, but even with filtering, we saw a lot of matrix that we knew that we were about to find matrix effects in our CMSMS acquisition. So those two leachate samples from those two materials were the most, I would say, challenging because when we dry down with nitrogen, with the nitrogen evaporator, everything just gets concentrated. So at the end, when we reconstitute, we will have all this that was in a 250 ml initial volume, all down to 1 ml. So all that matrix just concentrated as well with all of our analytes in the last 1 ml. So obviously this will translate into a higher background when we go to the LCMSMS portion, meaning that we won't be having as low detection limits as we would like to, or as, for example, compared to other materials. That was one of the challenges that we face during this study.
And if I remember correctly, you were going from solid phase extraction and then to nitrogen blowdown. Is that correct?
That's correct. Yeah. We initially received the leachate samples. The leachate samples were prepared in the lab in the engineering department with our collaborators. They were the ones that made all the leachate samples, and then they send those samples to us, and then we would have to. In my case, we would filter and then we prepare for the solid phase extraction. And then after the solid phase extraction, we have to elute those, taking out all the analytes that were captured in that sorbent material. After that, we have to blow it down with nitrogen using a nitrogen evaporator. In our case, to dryness, some people dry down to certain volumes. That's up to the type of chemicals that you are trying to analyze for. If those chemicals, your analytes, are very volatile, so you shouldn't dry down to complete dryness. But in our case, they were not volatile at all, so we just went ahead and dry down completely to dryness. And we reconstitute with starting mobile phase, usually with starting mobile phase and internal standard. That's how it's that's our way to operate. And then they're ready to be injected into LCMSMS. I'm not sure if you wanted me to go more in depth on on that process, but yeah, that was generally what we did. Yeah.
Very cool. And I believe for the blowdown step, you used a Organomation N-EVAP. How did that work for you?
Yeah, of course. Yeah, we use two system, and they work amazing. That's our first choice to use for our drying down process. And it's cool because you can change the flow rate at the pace that you really want. So you have a gentle stream of nitrogen. But if you want a higher flow rate, you can also change it. It's for me, it's worked wonders. It's been here for I'm not even. It's been there for years and years. It doesn't die. Like it's a good, very sturdy system. It really is. Yeah.
Awesome. Very happy to hear that. Regarding the project as a whole, what was the outcome you were most surprised by?
Yes, we found 6-PPD quinone, however, not as high as 6-PPD. And I thought, well, 6-PPD quinone should be higher in terms of concentrations because that's the main transformation product after oxidation. But for my surprise, I found way more 6-PPD coming out from the tire derived. Keep in mind that these tire-derived materials are from scrap tires that I would believe they're all were down, and so the 6-PPD, it shouldn't be there or not as much. But for my surprise, I found way more 6-PPD in the leachate samples rather than 6-PPD quinone. Now we can talk about the possibilities of why would we found 6-PPD over 6-PPD quinone, but also we found 6-PPD more in TDA, the tire derived aggregate, and rubber mulch, and in the other two, the tire asphalts, and there was another one, the RMA, the rubber mulch, and the tire asphalt. We didn't detect any 6-PPD, but TDA and rubber mulch, we detected very high concentrations. So that's something that we could talk about, and we can infer that the use of TDA and rubber mulch, maybe try to limit the use of those two tire derived materials in our environment, I would say.
Yeah, that makes a lot of sense. I
Yeah.
know there's a lot that's in process in terms of where this work is going, but would you mind talking about that as much as you're willing to?
Yeah, so from this project, a lot of questions arose from that. And one of them is if 6-PD and 6-PD quinone are everywhere, they probably made it to the wastewater treatment plants. And there are studies that found 6-PD quinone and 6-PD out from the wastewater treatment plants in the effluents. So with that being said, in that last step of the wastewater treatment plant process, they add chlorine, and chlorine is probably going to interact with all these compounds. We already know that chlorine produces all these disinfection byproducts that are toxic. Some of them are being regulated, but almost all of them are not. And we are very interested in knowing what forms after the chlorination of all these compounds and how toxic they are because they end up in our receiving waters and in rivers and most of them in the ocean. One of the directions that we're very interested in looking at soon.
That's very cool. I really appreciate the time today. Thanks so much, Jonathan.
Thank you. Thank you.